We're now going to move on to the next section of the course. This deals with externalities in resource use. Really, it's about environmental and resource economics. This material draws from chapter 18 of the textbook.
And the motivation for this section stems from the point that in a perfectly competitive market, welfare, that is consumer and producer surplus, is maximized where the marginal cost to produce a good is equal to the marginal worth of that good. That is to say, in a perfectly competitive market, we know that total surplus is maximized when supply equals demand. But what's also true is that the private market system often produces undesirable spillover effects on the environment. The production of goods and services sometimes creates problems with respect to air quality and water quality and environmental pollutants that can cause further problems for other people. Now, these are called externalities, and we call them an externality for a particular reason. And you'll see the logic behind this in a few minutes. But in terms of a definition, an externality occurs when a person's well-being or a firm's production capability is directly affected by the action of other consumers or firms rather than indirectly through changes in the price system. So what's going on here is that an action by one firm might impact another firm indirectly, and that effect is not going to be accounted for in the price that those firms pay for either their inputs or the price that they receive for their output. And so a good example of that might be if you live next door to a production facility that emits some kind of a noxious substance, the fumes from that production process might harm the neighbors, or at least they might find it unpleasant. Now, there's two kinds of externalities. There's a negative externality. There's also a positive externality. A negative externality is an externality that harms someone. This could be a smell from a chemical plant, or it could be that your neighbors keep you awake with their party. A positive externality is an externality that benefits others. So for instance, some manufacturing plants like to install outdoor shrubs and landscaping around the facilities so that it's not as, you don't just see this big ugly box that people work in. You actually have some amenity around that production facility that is a benefit to people who maybe pass by that plant. Another example of a positive externality are volunteers who clean up streams. Now, what's important here is that someone other than those responsible for that initial action suffers uncompensated monetary psychic costs. So if there's a negative externality, someone's production is causing someone else to bear a cost. On this other hand, if it's a positive externality, then someone's actions might benefit someone else who doesn't necessarily bear the cost of those actions. So what's important here is that when you have externalities, there's an action by one person affects another person, but there's no compensation for those effects. And it could either be compensation through paying for cleaning up water in the case of a negative externality, or not paying for a positive externality if you're the beneficiary of it. Now, there's all sorts of inefficiencies that arise because of externalities. And in fact, externalities lead to non-optimal production. In particular, polluting firms may not have to pay for the harms of their externalities, and because they don't face the costs associated with cleaning up the environmental externalities that they may generate, they may end up overproducing. And so to have production levels that are socially optimal, that is the most efficient outcome that we can find, we have to have decisions about resource use that take into account all costs. These costs can't just reflect the marginal cost of production, and the cost of production borne by the firm, but also the cost borne by others who have to deal with the externality that the firm's produced. Let's think of a concrete example to motivate this. So let's suppose that there's a farm that indirectly charges phosphate into a river. There could be water runoff, and through that runoff, phosphate gets into a nearby watershed in a river. And let's suppose that there's a town downstream that then has to treat the water so that it can be sent through the water mains, that is, so that people can actually drink it. Another example of how this action by the farm may affect others could be that the phosphates in the water reduce the number of fish in the river, thereby affecting downstream fishers in that there aren't as many fish to catch. Or the river might even look less attractive to some, affecting people who might like to swim or canoe in it. These are all these costs associated with either treating the water, a reduction in the number of fish, or having the river look less attractive are all external costs to the farm, but they're borne by someone other than the farmers. Now what's important here is that the costs don't necessarily have to be monetary costs. They could be the reduction in utility that someone receives because there's fewer fish in a stream, or it could be the reduction in utility that someone receives because a river is less attractive than they might necessarily like. So there's a big distinction here because we're talking about differences between the private cost, that is the cost borne by the farm, and the external cost. Those are the costs borne by the person who's affected by the externality. Okay, so just to review, those private costs are the costs of production only. They don't account for the externality. The external costs are those costs borne by someone else, external to the firm or the consumer, but internal to society as a whole. These are sometimes called third-party costs or spillover costs, and they're just the costs inflicted on people who are not directly involved in the economic transactions between buyers and sellers. Social costs are the sum of these two types of costs. It's private costs plus external costs. And those, remember, those external costs are the costs of harms from the externality. We can illustrate the impact of externalities using a simple supply and demand diagram. This diagram shows a demand curve in blue and the marginal cost of producing a good, MCP, in red. And let's just remind ourselves that in a perfectly competitive market with no externalities, the optimal thing to do would be for the firm to produce QC units of output and at a price of PC. Now, what's important here is that we're going to assume that every unit of output that the firm produces carries with it an externality, and someone else has to bear the cost of that externality. Now let's just suppose that we're dealing with that phosphate example again, and that the government is going to bear the cost of that externality because they then have to come through with a mitigation strategy that cleans the water before, let's say, it can be potable, that is, drinkable by people in the community. So government might bear a cost associated with that externality, and we can capture that with what we call the marginal cost of the externality curve. So that's MCG, and the little g is there to indicate that that's the marginal cost borne by government in cleaning up the externality. What we have to remind ourselves is that when we're dealing with an externality, we need to think about what would be the optimal thing to do when we account for the private and public or the social costs associated with an externality. To get at that, what we do is we add vertically MCG and MCP to get what we call a marginal social cost curve. And that's indicated by this darker red line with where it's MC subscript S is simply the sum of MCP and MCG. Now, what's going to happen is that we're going to still use our supply equals demand equilibrium concept, but now we're going to equate demand to the supply curve that is MCS. And when we do that, what we'll see is that because of after we account for the cost of the externality, the optimal thing to do would be for the firm to actually produce less output. In particular, what we're looking at is we want to find the equilibrium point here where MCS equals demand, and when that happens, we'll have an optimal level of output equal to QS, and price will rise. It will rise to PS. The only reason why price has risen is because there's less product available on the marketplace and you're facing a downward sloping demand curve. So what this shows is that after we account for the cost of government cleaning up the externality, the optimal thing insofar as social surplus is concerned is for the firm to produce less output. Now the firm might want to produce more output, but the reason why they would like to produce more output is because they don't bear the cost of the externality. As soon as we account for the cost of externality, we see that, in fact, the best thing that could happen is for the firm to produce less. Now, there's a couple other things that are important here. We can identify the cost of production, MCP, and we can also identify the cost of cleaning up that externality, MCG, at any quantity that the firm might choose to produce at. And the sum of those will give us the marginal social cost on the darker red supply curve. The other thing that's important is that the area below MCG tells us how much it's going to cost to clean up the externality. And so from a welfare point of view and from an economic point of view, the area below that MCG curve and between output with a competitive equilibrium and output when we're thinking about the socially optimal thing to do tells us the cost of that externality. In particular, that red trapezoid that I've just illustrated shows us the reduction in the costs associated with dealing with that externality when we go from output arising from a privately optimal solution, that is QC, to a socially optimal solution, which is QS. Now we can also measure that And in fact, it's easier to measure the welfare effects if we change how we measure the cost associated with that externality. And if we draw a line up from that competitive equilibrium to the MCS curve, and we relabel these areas as E, D, and H, you can show that in fact the cost reduction associated with shifting from QC to QS, that is the cost reduction in terms of the externality, is equal to area E, D, and H. So it's the area between the private marginal cost curve and the social marginal cost curve between those two levels of production. That's simply the reduction in the cost associated with dealing with the externality. Now that's a very powerful thing to do because we're then in a position where we can actually start to measure these things and think about the cost of externalities and different strategies to try to mitigate externalities. Now, there's a couple things that I want to emphasize here, and I'm going to say a few things a couple times just to really point out how important they are. We're assuming that pollution accompanies output, and that means that the competitive firm does not maximize social welfare. Right? So the firm is producing something that carries with it an externality, and because the firm doesn't deal with that externality, they're going to choose a level of output that's best for them but not necessarily best for society. So competitive firms produce too much phosphate because they don't have to pay for the harm of that pollution. This is what an economist would call a market failure. And this market failure results from the competitive focus equalizing price and private marginal costs rather than price and marginal social costs. Now, we can also think about broader welfare effects using this diagram. The areas E, D, and H become important, but we also need to label some other areas. And so we're going to put in place the letter A for the area below the demand curve and above PS. B is going to be for the area between PS and PC, but to the left of the marginal social cost curve. Area C is a little triangle below the marginal social cost curve, and area F and G are the respective areas as indicated. Now, all of those different areas are useful in measuring welfare. For instance, we know that if we were dealing with the socially optimal thing to do, that consumer surplus would equal area A. Private producer surplus, that is the benefits realized by the firm, are equal to area B plus C plus F plus G. The externality cost, that is the cost of cleaning up that externality, is equal to area C plus G. And so when we add private producer surplus and that externality cost, what we find is that the social producer surplus, that is PPS plus EC, is simply equal to area B plus F. And when we add consumer surplus and social producer surplus, we find that total welfare is equal to area A plus B plus F. Now, let's compare that to what would happen if we had a privately optimal solution. That is, if we had a competitive equilibrium where the firm and no one else accounts for the cost of the externality. Then what we would know is that the consumer surplus is equal to area A, B, C, and D. Private producer surplus would be equal to area F, G, and H, and the externality cost would be C plus D plus E plus G plus H, which is much larger, and social producer surplus would be area F minus C minus D minus E. And when we tally all of this up, what we would see is that we have total social welfare equal to A, B, F minus area E. Now, what I'd like to do is also think about what would happen if we go from the socially optimal solution, that is the solution that accounts for the cost of the externality, to the privately optimal solution, that is the solution that doesn't account for the cost of the externality. And what we would see is that, in fact, consumers are better off with that private solution. So too are firms. Their surplus is higher by area F minus B minus C. The externality cost with that private solution is also higher. It's area D, E, and H. When we add the private producer surplus plus the externality cost, what we see is that social producer surplus goes down when we go from what's socially optimal to do to what's privately optimal to do. And it goes down by area B, C, D, E. And when we tally all of these things together, what we find is that if we move from what would be socially best to what's privately best, that the change in total surplus is actually a loss. We lose area E. And so that area E is actually a deadweight loss associated with a privately optimal solution when you have an externality. And so this is often the reason why we see governments intervening in markets or in marketplaces or situations where there is an externality, it's because there's a deadweight loss associated with that externality that's not accounted for by the firm. Now we're going to go through a little bit of this in more detail in the lecture and also try to do a small game to illustrate these concepts. But I want to point out two really important things that are illustrated by that figure. The first is that a competitive market produces excess negative externalities. The privately optimal level of output is greater than the socially optimal level of output, and because each unit of output carries with it an externality, and those externalities aren't accounted for by the private system, too much of that good is produced, and therefore we have negative externalities being produced. The other point that's really important that often causes people in environmental sciences to have a little conniption about this is that the optimal amount of pollution is generally greater than zero. And in fact, what you can think about is that output, when we account for that externality, is not reduced to zero even after accounting for those external costs. And the reason it doesn't go to zero is that when we're doing this kind of calculation, we recognize that there might be some benefits associated with reduction in the externality, but there's also costs associated with reducing that externality. And when we think about this from a marginal benefits equals marginal cost point of view, what we see is that in fact it's not necessarily the case that one ought to eliminate all pollution, but that there's an economically optimal level of pollution such that the marginal benefits equals the marginal cost. And it's important that in that case that the marginal benefits are those for society at large and that the marginal costs are those for society at large, both private and public. This is a good place to stop. We'll pick up with this with some examples in class on Monday. I'll see you then.